Welcome you all. Sound. Okay, welcome you all. I am Dr. M. Devi, Assistant Professor, Department of Mathematics, DKM College for Women, Vellore. Today we are going to see about the introduction of graphs. A graph is a collection of points called vertices and a collection of lines called edges, each of which joins either a pair of points or a single point to itself. So mathematically it is noted as a ordered pair of V, E. Here V consists of the set of vertices and E consists of the set of edges. That is, edges is a ordered pair of vertices Vi and Vj. In the figure, G has a graph G has 4 vertices, namely V1, V2, V3, V4, and a graph G has 7 edges, namely E1, E2, E3, E4, E5, E6, E7. So in this graph, the edge E1 is connected by 2 vertices V1 and V2. Similarly for all other edges. So in short, we can represent G equal to V, E, where V consists of V1, V2, V3, V4, and E consists of E1, E2, E3, E4, E5, E6, E7. So next, self loop and parallel edges. Also self loop, if the n vertices Vi and Vj of any edge Eij are same, then the edge is called a self loop. So for example, in the previous graph, the edge E6 is a self loop because its starting and ending vertices is V3. Okay. So next is, if there are more than one edge is associated with the given pair of vertices, then those edge is called as a parallel or multiple edges. So in this previous example, the edge E4 and E7 are called as a parallel edges or multiple edges because its starting and ending vertices are V3 and V4. So next, simple and multiple graphs. A graph that has neither self loop nor parallel edges is called as a simple graph, otherwise it is called as a multiple graph. So weighted graph, suppose if each edge or vertices is named as some weights or labeling with some positive number is called as a weighted graph. So here the edge V1, V2 is labeled as 1.4. Next one is a finite and infinite graph. A graph is finite number of vertices as well as finite number of edges is called as a finite graph, otherwise it is called as a infinite graph. So in the previous example, the graph G1 and G2 is also a finite graph. So labeled graph is same as well as the weighted graph. Next one is adjacency and incidence matrix. So two vertices Vi and Vj or V1 and V2 vertices of G joins directly by at least one edge. Then these vertices are called as adjacent vertices. So in the previous example, the V1 and V2 are adjacent vertices because there is a connection between direct connection between the vertices V1 and V2. If Vi is an end vertex of edge Eij, then the edge Eij is said to be incident on Vi. Similarly, Eij is said to be incident on Vj. So degree of a vertices, degree of edges. The number of edges incident on a vertex Vi with a self loop is called as a with the self loop counted twice is called as a degree of a vertex Vi. So in this graph, the vertex V1. So there are 3 edges incident on the vertex V1. Therefore, the degree of a vertex V1 is 3. So there are 2 vertices incident on the 2 edges incident on the vertices V2. Therefore, the degree of the vertices V2 is 2. So similarly, okay, a vertex with the degree 0 is called as a isolated vertex, and a vertex with the degree 1 is called a pendant vertex. Suppose if the edge is a self loop, then it is counted as a twice. Handshaking lemma. A graph G with E number of edges and n number of vertices. Since each edge contributes 2 degree, then the sum of the degree of all the vertices in G is twice the number of edges. So summation degree of Vi equal to 2e is called as a handshaking lemma. Suppose how many edges are there in a graph with the 10 vertices? So each of edge degree 2. So how can we calculate or how can we implement the concept of handshaking lemma? The sum of the degree of the vertices is 6 into 10 equal to 60. So according to this lemma, it follows that 2e equal to 60. So there are 30 edges in the graph. So next one is matrix representation. So there are 2 types are available, adjacency matrix and incident matrix. So adjacency matrix. So adjacency matrix of a graph G with the n number of vertices and no parallel edge is called a symmetric binary matrix. A of G equal to Aij. Here Aij equal to 1. That is, there is an edge between Vi and Vj. If aij equal to 0, there is no edge between Vi and Vj, that is Vi and Vj are not adjacent. So, a self loop at a vertex Vi correspond to aij equal to 1. So, in this graph there is an edge between V1 and V2, therefore, the value is 1. There is no edge between V1 and V3, therefore, the value is 0. So, similarly, we have to fill all the values of this matrix. So, matrix representation. So, this is another example for adjacent matrix. So, next one, incident matrix. So, given a graph G with n vertices, e edges and no self loop, the incident matrix x of G equal to xij of the other graph G is not an n by e matrix. Here xij equal to 1 if the jth edge ej is incident on ith vertex Vi and xij equal to 0 otherwise. So, here there is an edge between V1 and V2, so therefore, the value is 1. There is no edge between direct edge between the vertices V1 and V3. Okay, so V1 and V3 are V1 and E3, so therefore, the value is 0. So, likewise, we have to fill all the values of this matrix. Directed graph or digraph. So, if each edge of the graph G has a direction, then the graph is called as a directed graph. The in degree, that is in a graph with the directed edges, the in degree of your vertex is denoted by degree minus of V and the out degree of the vertex is denoted by degree plus of V. So, directed graph or digraph. So, in this example, consider a vertex V, the in degree, that is edge is coming towards to A is 1, therefore, the in degree of A is 1. The edges coming out from A is 2, therefore, the out degree of the vertex A is 2. So, similarly, for vertices B, C, D, we have to calculate the in degree and the out degree of the vertices. Okay. So, next one, null graph. If the if the edge set of any graph with the n vertices is an empty set, then the graph is known as a null graph. So, here there is no edge. So, complete graph. Let a G be a simple graph on n vertices. If the degree of each vertex is n minus 1, then the graph is called as a complete graph. So, these are the examples for complete graph. So, the first graph, there is one vertex, therefore, it is K1. There are two vertices in the second graph, therefore, the graph name is K2. Likewise, there are 5 vertices in the graph K5, therefore, the graph is named as K5. Regular graph. If the degree of each vertex is same, say or in any graph G, then the graph is said to be a regular graph. So, biported graph. So, a graph is called a biported graph if the vertex set can be partitioned into two distinct subsets, say V1 and V2. So, the union of this two vertex set is V and the intersection of this two vertex set is empty, and each edge of G joins a vertex of V1 to the vertex V2. A graph cannot have a self loop. So, this is an example for biported graph. So, in the first graph is G1 is biported? No, because there is no way of partition of the vertices V1 and V2. Here the second graph is biported. Yes, the graph G2 is biported because we can display G2 like this way. So, isomorphism, two graphs are thought of as equivalent called isomorphic if they have identical behavior in terms of a graph theoretic properties. Suppose the graph, we have to consider two graph G of V comma E, G dash of V dash comma E dash. These are said to be isomorphic to each other if there is a one-to-one correspondence between these vertices and there is between the edges such that incidence relationship is preserved. That is, it is denoted by G1 is isomorphic to G2. So, consider this example. So, first one is G1, second graph is G2. So, the same number of vertices or the both graph, the G1 and the G2 have the same number of vertices and the same number of edges and the same degree of the vertices. Subgraph, a graph of a subgraph of a graph G is a subgraph G dash of V dash comma E dash, where V dash is a subset of E and E dash is a subset of E. So, spanning graph. So, a graph G dash is said to be spanning if the vertex set V dash is equal to the vertex set of V. So, complement of a graph. The complement of a graph is denoted by complement of G whose vertex set is same as vertex set of G and in which two vertices are adjacent if and only if they are not adjacent in G. So, operations on graph. So, first one is union of two simple graphs. That G1 is V1 and E1 and G2 is V2 and E2, and then simple graph with the vertex set V1 union V2. and edge set E1 union E2. Then the union is denoted by in this diagram. So next operations on graph, this is intersection of a graph. So intersection means the two graph G1 and G2, then the vertex set is empty and the edge set is also empty. Thank you.